The competition for Web3 dominance is heating up, and two names are now shaping the conversation more than ever. One pushes the limits of blockchain speed, the other challenges the entire idea of how decentralized applications should be built. Solana and the internet computer are moving in completely different directions, yet both are fighting for the same future: faster, smarter, and more open internet. This showdown isn't about which chain has more hype. It's about which one has the architecture to carry Web3 into its next era. Today's breakdown dives into what sets these networks apart, why their designs matter, and how each one could redefine the way the internet works. This video is created for educational and informational purposes only. It does not promote or endorse any financial product, investment, or cryptocurrency. All information presented here is based on publicly available sources and independent analysis. Viewers are encouraged to conduct their own research before making any financial or technological decisions. The conversation around Web3 usually circles back to a few major names. Ethereum dominates headlines because it has history, developers, and a massive ecosystem. Bitcoin stands apart as the foundation of digital money. But when the discussion turns to high-performance networks that can actually power the next era of the internet, two names consistently rise to the top: Internet Computer, ICP, and Solana. These two chains represent very different visions of Web3. One is built as a decentralized, cloud-level computer capable of running applications fully on-chain. The other is optimized for raw transactional speed and throughput. Both attract attention for unique reasons, and both have vocal communities that believe their chosen network is the future of blockchain technology. Understanding the differences is important because Web3 is shifting. Users want fast apps. Developers want simpler building tools. Investors want networks with real usage. And the next wave of dApps won't be simple swaps or meme token casinos. It will be social networks, AI systems, gaming platforms, and large-scale services used by millions. The goal is to break down how ICP and Solana differ at the technological, architectural, and practical levels. It looks at what each chain is good at, where each chain struggles, and what the future might look like if both continue growing. This isn't about hype. It's about understanding two very different approaches to the same mission: building a decentralized internet, a new era of Web3 infrastructure. There was a time when blockchains only needed to move tokens from one wallet to another. They were slow. They were expensive. They weren't designed for complex applications. When Ethereum popularized smart contracts, that was considered revolutionary. Suddenly, blockchains could run small programs, not just store addresses and balances. But as the space evolved, people started asking for more. Could blockchains run full applications instead of tiny? Could they replace centralized servers? Could they store content, not just transactions? Could they power AI models and large databases? That question opened the door for the new generation of high-performance blockchains. On one side stands Solana, a network built for speed, low fees, and high-volume transactions. Solana's vision is simple: scale layer 1 using hardware, parallel execution, and optimized consensus mechanics. On the other side stands Internet Computer, a blockchain built to remove cloud dependence entirely. Instead of only processing transactions, ICP runs full apps, websites, APIs, and systems directly on-chain. Both chains are fast, both chains are scalable, but the philosophies behind them are completely different, and that difference shapes everything, from developer experience to tokenomics to long-term potential. ICP, a decentralized cloud computer. Internet Computer takes a bold approach. Instead of managing smart contracts the way Ethereum does, ICP introduces canister smart contracts. These canisters are powerful compute units capable of storing data, running complex logic, and even serving web content. A canister is more than a contract. It is a fully managed software container that behaves like a microserver inside the blockchain. This is why ICP can run things that other blockchains cannot: social networks, messaging apps, gaming backends, full websites, and advanced AI. Another key difference is how ICP treats the idea of decentralization. Most blockchains rely heavily on centralized cloud platforms, whether people want to admit it or not. Solana RPC nodes live on AWS and Google Cloud. Ethereum infrastructure providers rely on these services too. ICP removes that dependency. Its network is powered by independent data centers that host specialized hardware machines. These machines form subnets, and subnets form the global Internet Computer. The goal is a true alternative to traditional cloud computing. This approach allows something Web3 has been promising since day one: the ability to build applications that exist entirely on-chain, with no servers, no centralized APIs, and no cloud accounts. A developer can deploy a full service to the blockchain and forget about infrastructure management. This makes ICP different not just from Solana, but from almost every other blockchain in existence. Solana, high-speed transaction engine. Solana, meanwhile, is laser-focused on performance. Its architecture prioritizes fast block times, high throughput, and parallel execution. The network can process tens of thousands of transactions per second at very low cost. It accomplishes this through several innovations. Parallel execution through C-level allows many smart contracts to be processed at once. Proof of history creates a global time source, so nodes don't waste time agreeing on ordering. Validator hardware scaling pushes performance by encouraging high-spec machines. It's a pragmatic approach. Solana aims to solve the largest weaknesses of early blockchains: slow processing and high fees. This results in excellent performance for decentralized exchanges, payment systems, and token-based applications. Solana is the go-to chain for high-volume applications. NFT markets, trading bots, and DeFi platforms benefit from Solana's speed. But this speed comes with a trade-off. Solana still relies heavily on cloud infrastructure. Many validators run through centralized hosting providers. The network needs powerful hardware to operate, and although Solana's ecosystem is large, most applications still use off-chain or cloud-based components. This doesn't make Solana weak. It makes Solana extremely optimized for a specific purpose: efficient, fast, low-cost transactions. Scalability, cloud versus chain. Both ICP and Solana claim to scale better than older blockchains, but their methods differ drastically. Solana scales vertically. Faster hardware, prispaßt faster blockchain. More cores, prispaßt more throughput. More memory, prispaßt more parallel execution. This is similar to upgrading a computer. It works well, but it leans on a simple idea. To scale, the machines must get stronger. ICP scales horizontally. More subnets, whereas more capacity. More data centers, whereas more compute. More canisters, whereas more applications. This is similar to scaling a cloud platform like AWS. You don't rely on bigger machines, you rely on more machines. Solana treats the network like a super-fast ledger. ICP treats the network like a distributed cloud. These aren't small differences. They shape the entire future of both chains. Developer experience. Contracts versus canisters. Building on Solana involves writing programs in Rust or C, deploying them as smart contracts, and often connecting them to external APIs, servers, and databases. Solana programs are extremely efficient, but they're also limited. They aren't built to host full services or store large amounts of data. ICP, on the other hand, allows developers to build full-stack apps directly inside the network. Storage, back-end logic, front-end, APIs, all can live inside canister smart contracts. This drastically reduces infrastructure complexity for developers. The question becomes, what does a developer want to build? Simple swaps, bots, payments, and mint mechanics to Solana fits perfectly. Full social platforms, AI systems, privacy tools, and large-scale Web3 apps to ICP is more suitable. Ecosystem comparison. Solana has a vibrant, energetic, fast-growing ecosystem. Meme tokens, DeFi protocols, NFT markets, payment networks, and trading platforms dominate the scene. The chain is ideal for fast financial interactions, which draw heavy user traffic. ICP's ecosystem is smaller but structured differently. It focuses on long-term, utility-driven applications. Social networks, decentralized messaging, AI models, identity systems, and governance DAOs are more common. Solana wins in user volume, ICP wins in architectural depth. As Web3 evolves, both types of ecosystems will be needed. Reliability and network stability. Solana has historically struggled with network outages. These events are less frequent now, but they remain part of its reputation. Speed comes with complexity, and complexity increases the chances of downtime. ICP, by design, isolates subnets so failures don't affect the entire network. The chain has maintained strong uptime since launch. Subnet upgrades occur autonomously without disrupting services. Reliability matters for applications that need uninterrupted performance, which is why ICP attracts developers building mission-critical systems. Security and governance. Both networks have strong security models, but again, the approaches differ. Solana uses traditional validators, stake tokens to run a validator to secure the network. It works, but it relies heavily on hardware and cloud providers. ICP uses chain key cryptography and the network nervous system, NNS. The NNS allows the network to upgrade itself, create new subnets, and manage configuration without downtime. Chain key cryptography enables direct communication between chains and subnets without bridges. This makes ICP uniquely positioned for cross-chain messaging. Solana can scale transactions, but ICP can scale communication between systems. AI and the future of Web3. AI is becoming the next big battlefront in blockchain. Running AI models requires storage, compute power, and data processing, things traditional blockchains aren't designed for. Solana can host AI integrations, but the heavy compute still happens off-chain using cloud services. ICP can run AI models inside canisters. This means inference, training, and interaction can happen directly on-chain. This is something no other major blockchain can currently match. AI may be the deciding factor in the next wave of Web3 infrastructure. The chain that handles AI workloads best could become the backbone of the decentralized internet. The real question: which chain wins? The answer is not simple because ICP and Solana are not trying to solve the same problem. Solana is built for speed, liquidity, and high-throughput interactions. It wants to power markets, trading systems, and financial applications. ICP is built as a decentralized computer. It wants to replace cloud servers, host full applications, and merge AI with blockchain. Both are strong, both will grow, but they lead different categories. Solana will continue to dominate high-speed DeFi and consumer token activity. It has volume, speed, and massive user flow. ICP will continue to dominate decentralized compute, AI, and fully on-chain applications. It has architecture, scalability, and advanced technology. The real future of Web3 likely includes both. ICP and Solana represent two powerful but very different visions for Web3's evolution. One optimizes speed and high-volume activity. The other redefines what a blockchain can be by turning it into a decentralized computer. This isn't a rivalry where one chain must destroy the other. Instead, it's a race to build the next generation of digital infrastructure. Some apps need speed, some need compute, some need decentralization, some need a mix of all three. What matters is this: the days of simple smart contract chains are ending. Users want full apps, not just tokens. Developers want performance without centralized servers. AI is demanding more complex compute environments, and the internet itself is shifting toward decentralization. In that future, both ICP and Solana will play major roles. All right, if you learned something new or enjoyed this video, make sure to hit that like button, subscribe to the channel, and turn on the bell icon so you don't miss future updates. Thanks for watching, and I'll see you in the next one.